Hello and welcome to Do Dancing Clams. This tutorial describes a simple method for generating a moon using both geometry nodes and procedural textures working together. The cratering effect is achieved using distribute points on faces with transfer attribute to pass the crater radius back to the sphere's mesh. While it is used somewhat subtly here, the same technique can be used unsubtly to create a sea-urchin or even a sponge-like result. The dark seas are created with a noise texture, which is used to control both the amount of flattening of the mesh as well as the darkness of the texture. This nicely simulates the lava flows on our moon that created the dark patches, or Maria. This is one of my favorite Blender projects so far. Not only did I learn a lot while creating it, and the results are better than I hoped, but the final project file is much simpler than I was envisioning, especially the procedural texture. I hope you enjoy it too. The project file for this tutorial is available on Gumroad. Just follow the link below. We'll start, as is tradition, with making sure Node Wrangler is enabled. Let's go to Edit, Preferences, go to the Add-ons, search for Node Wrangler. It is on. Next, I'm going to drag up this window and change it into geometry nodes. We'll be using spheres. Let's go ahead and create that. And we'll have the radius of it be controllable. Let's give that a better name. And I want to max out the subdivisions because we need the detail to play with. We're going to have a cloud of points define the center of each crater. So let's go ahead and create that with distribute points on faces. Now, the algorithm depends on craters not overlapping, but in order to achieve the final result we want, we need to have overlapping craters. So the way we get around this is, in any given pass, the craters will not overlap, but we will do multiple passes, adding more and more craters with each pass. So I'm going to accomplish that using daisy-chained node groups. Let's go ahead and create that node group right now. Control G to create it. We don't need selection, but we do want controls for density and seed. And we also want a control for the crater radius. I know I want Poisson disk. Again, that allows us to specify the space in between craters. And I know I don't want the craters to overlap, so let's multiply the radius by 2 and use that as the minimum, well, the function is maximum, use that as the closest spacing we'll allow for craters on an individual layer. Let's go ahead and give ourselves something to look at. That's better. Back into our node group. And we're going to call this crater group. Tab back in. Okay. Now, these points will be used to store the radius of the crater. So I want to do that with a store named attribute. And we'll call this attribute crater radius. And then we will transfer this attribute to whoever asks for it. And just go ahead and use nearest. And the attribute will be the one we just created. Now this looks really strange it looks like what we're doing is storing an attribute and then immediately transferring it. But that's not the way it works because this is field-based. What's going to happen is we will be looking at a single point on the sphere. And we will come back here and we'll ask it for the nearest point in our point cloud. And then we will transfer from that point the radius and its position. And we'll use that to guide the crater deformation. So even though it looks like this is kind of stupid, it's actually what's necessary. And as I just said, now we'll start working on the nodes that are going to actually do the displacement. The vector math node. And I'm going to want to know the distance between our current position and the position of one of the points in the cloud. That will control how far from the center of the crater we are. Next, I want to know how far we are from the center as opposed to how far the current position of the surface is from the center. So we'll do a divide by the radius. And this will give us a number between 0 and 1 that tells how far from the center of the moon we are. Because we are doing multiple passes, we can't just always offset from where the surface of the moon was. We have to offset from where it currently is. For the radius, we're going to start with a random number between 0 and 1. And technically, since we're going to do multiple passes, I wouldn't necessarily have to do this, but what I've noticed is by providing some randomness to the size of the craters in each step, fewer steps are required. So it's just a little bit neater. Next, we'll determine the radius of a crater. So we get that by multiplying this number that's determined between 0 and 1 and the radius, the crater radius that the user gave us. Next, we want to know the distance between the nearest point in the point cloud we selected and our current position. This determines whether we're closer to the edge of the crater or at the center of the crater. And obviously we deflect more at the center of the crater and less at the edges. Do a division to get a number between 0 and 1. And we will feed this into a float curve. One more quick step first. Instead of a number between 0 and 1, we want a number between 1 and 0. Really hate doing all this work without being able to see anything, but in this case it can't be helped. So, what we want is a curve that represents the edge of a crater. So a crater starts off pretty smooth, and it goes up to a lip, and I'm going to make this a crease, and it goes down to the middle, something like that. Yeah, so the plane of the moon will come through, will be at this level, and then rise up to a little lip, then that'll cast a nice shadow, and then down to the crater. And then this is the midpoint of the crater. We want this point here to be level with the current surface of the moon. So we want to make sure this value corresponds to 0. So we could just kind of ad hoc it or like subtract 0.73, whatever, as it tells us to do here. But the problem with that is if we go and reshape the curve, every time we did that, we'd have to change this number. A quick and easy way I found to get around this is call this a group, go back out, call this let's duplicate it. So we want that to go into the value, and we want the value here to be 0. So this will get us the first value always, that 0.7, and this will get us the field value for where we currently are, the crater. So I subtract these, and no matter what I do, the beginning of the curve will be at the same level as we currently are on the surface. Now I want to determine the depth of the crater. So the first thing we'll do is take this value from the curve edge and multiply it by the crater radius. So by default, wider craters will also be deeper in the middle. Smaller craters will be shallower in the middle. That only makes sense. Also, this will be controlled by allowing the users to specify. So let me get another group input node just for convenience, and we will create a new value. And I'll call this one depth. We will use this value to take the normal So because we're dealing with points on a sphere, the normal basically points from the center of the sphere out toward the edge. So by multiplying these two together, essentially I'm controlling how far from the center each point is. This is the amount I want to displace it by, and I just have to add in our current position to move it. Now I can do a set position. I don't know why it always goes to selection. And we got these, we don't need them. We do want that, so let's go ahead and kill these and call this geometry because that's what it is. Just a couple more steps and we'll be able to see something. So I want to hook up the geometry. And I want to stop this math from affecting anything outside the current crater we're working on. So let's do a selection to select only those points that are close to the crater. So I'll do a compare less than to 1. And I know that this value over here is a number between 0 and 1, expressing how close to the crater edge we are. So if we're beyond that, we don't want to have any effect. And I also now just noticed that these are backwards, so let's fix that. Hook this up. Now I want to give our moon a decent radius so we can have craters nicely spaced out. And let's give our craters a... I'd like to subdivide the mesh now. And make this a controllable parameter. It's nice to render the mesh at level 2 or 3, but it's also a pain to work with when it's that detailed. And I also want to go back into this group and chain the seed value on through. So basically pass it from the beginning to end and change it. Adding one is fine. Basically, this allows us to daisy chain the seed values and have a different one per instance. If we didn't do this, the same point on faces would be used at every level, and the craters would just stack up. Now we can make the render a bit more interesting. Duplicate this a few times. Let the control the seed from here, and also chain it through like we were just talking about. Now for some values. I like to start at the big craters and go on down, so 10 is fine for this, with a spacing of 15 or so, and a depth of about 2.5. Actually, let me flip these two real fast. And this one will go for radius of 4 is good, spacing of 7, and about 1.5 for the depth. And on this one, go for radius of 2.1, density of about 4, depth of about 1, and essentially do that again. This is basic to create more of the small craters, give a little variation to the depth. It's looking pretty nice. And you can see cranking up the detail really helps sharpen up the limb of the craters. Let's go ahead and add a shade smooth. Now's a good time to add the texture. So to set up for that, go ahead and switch to the cycles and GPU to make it run faster, and make sure we're in render mode. Go ahead and change the light source to a sun. I mean, when was it ever more appropriate? And create a new texture. Call this moon. Very creative. And go ahead and assign it here. And I will go ahead and create the texture. Now, usually you do this inside the shader editor, but I want to use the exact same noise to flatten out the dark areas of the moon and create the dark areas of the moon in the shader. Let's go ahead and do it now. Create this as 4D and make it controllable from the outside, just so you can rapidly scroll through different patterns of light and dark to find one that's pleasing. Call this texture seed. And I want fine control over the scale. So let's go ahead and throw in a divide by 10. And we can leave it at that value for now. Change it later if we want to. And I want to do a store named attribute. Call this noise. So this store named attribute will not only make it available later on down the chain in the geometry nodes, but will also make it available inside the shader editor. Go ahead and do that now. So we fetch that named attribute with an attribute node and give it noise. Now we should see something. Not a lot of change, but it got a little bit darker in areas. I want to sharpen up the dark and the light areas, so let's add a color ramp. Let's scoot this one up to about close to 0.4 and leave it black. Let's create a new one. Shove a little closer. Go ahead and change this one to 84, darken it down a bit. 84 is across the board. And change this one to Alpha Dog all the way down. Perfect. Well, not perfect, but good. Let's roughen it up a bit because moons aren't supposed to be shiny. That will do for now. We'll grade up a bit right now. So I'll start with the noise texture, and this is basically going to provide a gritty look across the surface. So we'll turn the scale way up, as well as the detail. Send this to a map range node. The only thing I'm using the map range for here is to turn down the color, so I want it to top out at kind of a medium gray. So I'll make this a 0.6. And we'll mix these together with a mix RGB. And for this, we'll just throw in a little bit of the gray. So this will take some of the harshness out of the blacks, so down to a more dark gray, which is, I think, more naturalistic looking. Cool. We'll use this as our bump map to give a speckly effect across the surface. And as usual, it's way too strong, so turn it down to about a 0.2. Cool. And that's all we have to do with the texture. You can do more, add more ranges, but in this case, I think less is more. So let's go back and finish up the geometry nodes. Now, as I said earlier, I want to flatten out these black areas to correspond with the basaltic flows on the moon, where lava came out and not only turned the surface of the moon darker, but also erased the craters. So I'm going to do that with a set position. Now, to do that, I'm basically going to measure the difference between the current position and where the radius of the moon is set, and then make that distance smaller depending on the color, and then add it back to the original position to get a new position. So start with measuring the distance. And we'll use a distance node. And go ahead and get a copy of this. And we will subtract the original radius of the moon. Now I want to multiply this by essentially the color value, and that's our named attribute. Add that and okay, so So again, the point of this was to take a distance between where the position currently is and the original surface of the moon, modify it with the noise value, and then coming down here, we'll take the position and run it through normalize, which basically gives us a vector pointed out toward the place where we are. And by multiplying this new distance value with the normal vector, we get a new height. And then we plug that in the moon, we get the flattening effect. Now, this is not what I want because the white areas got hit a bit more than I wanted to, and the black areas got hit a bit less than I wanted to. So the obvious thing to do would be to change this over here, but I don't want to do that because I'm happy with where the colors are. So what I really want to do is run this through a float curve, run the exact same data through a float curve to alter it to do more with the surface while leaving the data for the shader editor alone. So we will do a store named attribute, and we will call this one mare because we're using it for the seas. Go ahead and hook this up. And I notice that this needs to go to the value. And go ahead and change this to from the noise texture is using. We won't see a difference yet because we haven't done anything. So what we want is to flatten out the dark areas more, the value is closer to 0, but leave the white areas alone. That's pretty good. And let me go ahead and give a little bit more detail. Yeah, I like that. Of course, we can endlessly fiddle with these values. Go ahead and change this to integer. And now it's just a question of like playing with it until you get the visual effect you want. And of course, can turn up the detail to render. Yeah, I think that's got it. Like I said earlier, these techniques are pretty general. For example, the pushing a surface out based on points scattered across the surface. If you push them like in a lot, you get a more sponge-like texture. If you push them out a lot, you get a more sea-urchin-like creature texture. I think this I'm going to use this technique for a lot of different things. Anyway, I hope you enjoyed watching this video as much as I enjoyed making it. Catch you next time.